Let's talk about the unseen guardian of our electrical grid. It stops failures worth millions.
And yeah, we're not talking small glitches. A single surge can mean millions in catastrophic damage.
The grid is under constant attack. Lightning, switching surges, they can destroy vital equipment in a flash.
So how do you possibly protect against that? You need a guardian that reacts in nanoseconds.
And that's where the surge arrestor comes in. It's basically the unsung hero of the entire grid.
So how does it work? The best analogy is a pressure relief valve, but, for electricity. It does nothing during normal operation, but when a surge hits, bam, it instantly opens a path to safety.
So how do you pick the right one? Well, it all comes down to 3 critical parameters. First up is MCOV. Get this wrong and your arrestor could fail in months, not decades.
Luckily, picking the right MCOV isn't a guessing game. It's a clear 3-step process.
And here's a really common mistake. Always use the maximum system voltage, not the nominal one.
Okay, so the arrestor can survive, but how much protection does it actually give your equipment?
That's called residual voltage. It's what gets through to the equipment. The lower, the better.
You need a safety gap. The equipment's strength has to be way higher than what the arrestor lets through. So how big should that gap be? Well, the industry standard is a minimum safety margin of 20%.
All right, last parameter. A surge isn't just voltage, it's a massive blast of energy, which means heat.
And that's where the energy rating comes in. It tells you exactly how big of a hit it can take.
And it really depends on the job. Different applications mean different energy levels, so you need different arrestor classes. Here's a great rule of thumb from the experts. When in doubt, go 1 class higher. It's cheap insurance.
But remember, lab ratings are just a starting point. The real world, altitude, pollution, it all matters.
See? Picking an arrestor isn't just grabbing a part. It's about creating a smart defense strategy.
So that leaves one big question, right? Is your grid's silent guardian actually up to the task?